20 years ago, a seed was planted and cared for. We painstakingly nurtured it and weathered it against adversity until one day it blossomed and the fruits of our labor began to show. Today, millions have learned, shared, and been inspired by what our community has produced. We proudly serve 21 million users from 204 countries in 2019. Through our 85,000 technical articles, code samples, and videos, our 450,000 forum questions, and our highly anticipated conferences and events featuring keynote panels, live streams, and industry experts and influencers, we recognize and reward members for their dedication to the community. Through content contributions and mentorships, we ranked number 2,620 in the world with a reach of millions across our social media channels. Thanks to you, our global community of software and data developers grows stronger each day. For more information, visit us at CSharpCorner.com.
Good morning, everyone. Welcome to the Kubernetes Fundamentals series. This is session 4. My name is Rodrigo. And today I'll be talking about pods, ReplicaSets, and deployments. So let's get started, shall we? So before we describe what ReplicaSets are and deployments, let's do a short and quick recap about the things that we've seen up to this point. As you might remember, we were talking about the fundamental resources that we can deploy in a Kubernetes cluster. Of course, we want to run our container applications, right? So we have our containers, and those containers will be deployed into a pod. The pod is the smallest object that we can deploy in a Kubernetes cluster. Okay, that's where your containers are. You can have one container, or you can have more than one container if you're, I don't know, implementing the sidecar design pattern or other design patterns that use more than one container. And those pods, it's quite strange if you deploy them directly. That's actually, I don't think that's something quite real world. Actually, you don't deploy your pods directly. What you use is a replica set. And the replica set is this object that allows you to replicate the pods. And actually, it has the configuration about how many pods you want in your Kubernetes cluster at a given time. And then you use the deployment. Actually, the deployment, I think that's more common. You create a deployment YAML file, and you deploy that YAML file to create the deployment itself. And the deployment has inside a replica set, which in turn has the definition of the pod that you want and how many replicas of that pod you want, okay? So as I mentioned before, you can have more than one container. And there are other objects that we can deploy in a Kubernetes cluster. I'm going to talk about that maybe today, maybe in the next session, such as the service object. Anyways, then we explain the imperative versus the declarative approach of defining things. I mentioned before that the imperative way is when you type the commands, and those commands will execute and change the things that you're specifying in those specific lines. One of the things about the imperative way is that you're explicitly telling Kubernetes what to do, okay? Instead, we use the declarative way. I think that's more real world. Actually, if you're looking for the CKA or CKAD certifications, you're going to be presented with a lot of YAML files, because that's the way that we use for this declarative approach. You can use YAML, you can use JSON. So the difference is that with this kind of text files, you are describing what you want. And Kubernetes is gonna accomplish what you're trying to implement, okay? Because Kubernetes is based on this desired state thing. So you're declaring the desired state of things, and Kubernetes is gonna um, fulfill that desire for you, okay? So, and then we talked about that declarative is the preferred way, as I mentioned before. And we can also use a hybrid approach, which is just execute your imperative commands and obtain the YAML or JSON structure, and then use that for creating your declarative manifest files. So here's an example of creating a pod by using kubectl run. Kubectl run is the command that we use to create a pod. In this case, it's creating a my-nginx, that's the name of the pod, and it's using the nginx image. If you don't specify a fully qualified name, it's going to use the Docker Hub registry, which is the default, okay? And here's another example of creating a namespace. I'm gonna talk about namespaces in the following sessions. So as you can see, I'm using kubectl again. This time it's using the create command for creating this namespace. Here's another example of the declarative approach. Actually, we created a manifest file from scratch by using Visual Studio Code and some of its plugins for creating these YAML files. In this case, as you can see, we have 4 main elements such as API version, kind, metadata, and spec. So API version is the API version that you want to use. It's related to the Kubernetes version that you're using. Kind is the kind of object that you want to deploy. Metadata is the group of all the metadata elements that you want to specify for this particular object. And finally, spec is the place where you specify the traits of that particular pod. In this case, it's just specifying that the name will be nginx, and it's based on the nginx image. So with the hybrid approach, as I mentioned before, we can use this command to output the YAML content and then create a YAML file. So you can use it directly, maybe not, maybe just use the structure for as a baseline, right? And well, actually, I think that's pretty handy. Other commands: kubectl delete for deleting objects, kubectl edit for editing objects, and finally kubectl replace for replacing the properties of a specific object inside the cluster. I mentioned the difference between kubectl create and kubectl apply. The difference is that kubectl apply, if the object doesn't exist, it will be created. And kubectl create, if the object doesn't exist, is going to return an error. That's the difference, okay? So I mentioned the manifest files. Those are the files that we create by using, actually, you can do that from scratch if you're willing to do it. However, there are a lot of applications and templates that we can use, such as the ones that we can find in Visual Studio Code. So for instance, let me open here the terminal, and let's create session 4, right? And let's open up Visual Studio Code. And here, I just want to create a demo.yaml file. And here, I'm gonna use pod. And as you can see, I have this IntelliSense thing. So I can press tab, and I have this nice placeholders that I can use for specifying some of the elements in some of the values of those elements in this file, such as, I don't know, my awesome pod or something, and then the image, I don't know, nginx again, and the port will be 80 or something, right? So I have already a manifest files for creating a pod. This is great. Of course, you can do that, or you just can, of course, type API version, then kind, right? And then metadata, and finally spec, and then you create all those different elements. However, you need to know the different properties and the structure of that particular object that you want to create. I don't remember if I mentioned that before. However, we have the kubectl explain. Man, I think I didn't mention this. Kubectl explain is awesome because it allows you to obtain the help for a particular element in a manifest file. For instance, I don't know, I want to know more about metadata.name. So you execute this command, and this will return the help for this particular element. Of course, this is going to return an error because I don't have a cluster yet. Let's do that. Let's run the terminal as an administrator. And here, I'm going to do the following. Remember that we're using Minikube as the technology for deploying the cluster. So I can run Minikube delete. So this is going to delete all the different virtual machines that were before. And let me show you that. I'm going to open up Hyper-V Manager. And this is deleting those virtual machines, right? So this is stopping the virtual machines, deleting the virtual machines, and then I can create a new cluster. So let's wait for this. And again, Minikube, start, and then the driver will be Hyper-V, and then the nodes will be, let's say, 3. And this is going to deploy a cluster with 3 nodes, okay? So let's wait for that. In the meantime, let's go ahead and continue with the this recap. I mentioned API version, which is the version of the API that you want to use, right? We can use the API versions command to obtain all the different compatible API versions that your cluster supports. The kind is the kind of object that you want to deploy. Metadata, here is the place where you specify all the different traits about that particular object in metadata, such as name, namespace, labels, and annotations, and some other things. And finally, spec, which is the specification of that object per se, okay? So when you create those objects in your cluster, each object has an auto-generated UID. Actually, you don't manage those IDs directly or reference those IDs directly. However, is something that you should know. Each object has its own identity. Then I talked about pods, which is the primitive object for running an application. This is the place where you deploy your containers. Okay, this is the smallest object that we can create in a Kubernetes cluster. And generally speaking, there's a one-on-one mapping between a pod and a container. And of course, you can deploy more than one container in a single pod for some scenarios, such as in containers, the ambassador pattern, the adapter pattern, or the sidecar pattern that is used by Dapper, which is a fantastic framework for creating distributed applications and microservices. Actually, Dapper is based on this sidecar design pattern. So actually, what you use is the pod for deploying your containers. However, you don't scale an application by just adding more containers to a pod, okay? You don't do that. What you use is a replica set, and that's what I'm going to explain today. Cool. I mentioned the lifecycle of pods and some of the commands that we can use to manage pods. So let's wait for this cluster to be created. As you can see, those 3 virtual machines are already deployed. and it looks like it's going to finish sometime soon or not. Okay, let's wait for this. Anyways, there are other container, there are states for containers as well. We have the life cycle states for the pods, and we also have container states. So you can know if a container is running or it's not. Cool. So let's talk about replica sets. So this object, it allows you to specify a number of pods that you want to execute at any point. So this is based on the promise theory that Kubernetes implements. So that promise theory is related to the desired state of things. So you define this desired state, and Kubernetes is going to fulfill that desired state for you automatically. You don't have to do anything about that. That's actually what one of the objectives and goals of Kubernetes. Okay, so you can use this replica set object independently. However, usually we define it inside a deployment. A deployment in itself has a replica set. That's an inherent replica set. Okay. Back in the day, some years ago, we had the replication controller. And actually, that's the original form of replication in Kubernetes. Then ReplicaSet was created. I think this is the way to go nowadays. But of course, if you, I don't know, maybe if you open a book about Kubernetes, an old one, or a video or a blog post about Kubernetes, and if it's, I don't know, if it's, maybe 3 years from now, or it's older than that, then you can see the replication controller being mentioned. However, ReplicaSet is the way to go, okay? So cool. How can we create the ReplicaSet objects? So let's go back here to the terminal. kubectl get nodes. Let me execute this to know if everything is running correctly. Config get nodes. Is that it? Config, get nodes. I'm sorry. And the other one is config. I can remember the other command for obtaining the information about the cluster. Anyways, this is running. Okay, I have 3 nodes, and I want to execute the other command that I was telling you about, which is explain pod metadata.name. In this case, as you can see, it's telling me the description about that particular element inside the pod object. So I'm obtaining this help, this contextual help about that here in the terminal, which is great. I think this is a great way to learn about the Kubernetes objects. Another example could be, I don't know, specs. This is spec and then containers. Is that the name? Yes, containers. So as you can see, for instance, this containers element has args, command, env, from, image, liveness pro, names, the name, ports, and so on, and so on, and so on. So I'm telling you this because this is a great way to understand the structure of objects in Kubernetes, okay? So let's go back here and let's open up Visual Studio Code again. I'm gonna open up this demo.yaml file again. But this time I'm going to use the repli word, and then I'm gonna press tab. As you can see, I'm creating a replication controller. This is the one that I was telling you about, that this is the old object. And of course, this is not going to work. Of course, it's going to work, but I don't want to deploy this kind of object, okay? I need something to tell me the the structure of the replica set. I want to create a replica set. I believe this plugin that has the replication controller template doesn't have the replica set template. However, let's search for this in the Kubernetes documentation, ReplicaSet, Kubernetes schema or something, right? And here's the ReplicaSet. And here's an explanation about ReplicaSets. And I'm gonna copy this, okay? And I think that's enough, okay? So let's do this. I'm gonna create this ReplicaSet. I think the difference is in the match labels element. I'm not sure. I mean, the difference between ReplicaSet and replication controller. Anyways, as you can see, the API version is different. This is one of the differences because replication controller uses the V1 API version, and ReplicaSet is using apps/V1. So we have API version, kind, metadata, just the regular stuff that I told you about. Of course, I'm going to explain labels and some other things such as match labels and annotations later in this series, okay? However, here, as you can see, inside this spec element, we have the replicas element. With this value, you're telling Kubernetes how many replicas you want for this specific pod. So in other words, you don't need to specify a replica set inside the spec. You just specify your pod, and then with the replicas element, you're telling how many replicas you want, okay? And in this case, it's going to create this PHP Redis container. Actually, let's do this. My Nginx, and then again, and just this is because this is the image that I've been using since day one. So I think this is great. Nginx. This is a typo. Nginx. My Nginx. Okay. So this is the structure of a replica set object. Actually, it's very similar to the pod specification. Actually, this is the pod specification. Okay, so let's do this. My pod.yaml. Let's create a pod just to see the differences side by side. So this is the pod, okay, and this is the replica set. And if we compare the spec, actually, it's almost the same. Actually, you know what? This is the pod. This spec that is inside this other spec. This is the spec for the replica set. And this is the spec for the pod, okay? So this is the comparison. This one against this other one, okay? So inside the spec of the replica set is the replicas element that you use for specifying how many replicas you want. And you have other things such as selectors, match labels, and so on. And here's the pod, okay? So as you can see, this is like a copy of the pod spec. Actually, if you copy this and then you paste this inside the spec, this should work. This should totally work, okay? In theory, this should work. Actually, you know what? Let's do this. So I just want to get rid of the resources element because I don't want to talk about resources today. And my Nginx, and then the image should be Nginx, and this should work, okay? This is actually what we had before I deleted the entire element. So actually, I'm going to just undo the changes because I don't want to mess with the names. This is the thing, that the code that I pasted, let me show you one thing. because this is not going to work if I continue with this, okay? So let's close this. And again, I have API version, kind, metadata, and the spec. This is the spec for the replica set, the spec for the pod. Why in the world this is not going to work if I deleted these other elements? Well, actually, I wasn't deleting this. I was just changing the name of the image. The thing is, I don't want to confuse you today. The thing is that those labels are quite important. Those labels are the way that the replica set uses for detecting what are the pods that this replica set object is going to manage. Okay, that's the reason why I'm explaining and I'm mentioning this. Anyways, bear with me, friends. Okay, we're going to see labels later in this series. Okay, so my Nginx, Nginx. This is safe to change. This is nothing wrong. Okay. This is just using the front end labels, which is fine. Those pods will have the front end labels, and that's great. Okay. So let's try to deploy this. Let's go back to the terminal, and I have those couple of files, and then kubectl apply, and then the file, and then the demo.yaml file. So as you can see, the ReplicaSet object was created successfully. At least this is the status that the apply command is telling me. And how can we know if those pods were created and the ReplicaSet was created? So remember that we have the get command, and you specify the name of the object that you want to query. In this case, I'm going to use pods. I could be using pod as well. Pod or pods is the same. So as you can see, this is creating those pods. And actually, those 3 pods are running correctly. So let's go back here to Visual Studio Code, and let's change the replicas to 10 instead of 3. And let's run again the apply command. Okay, I'm changing the replica set object. And now if I execute the get pods command again, you can see that now I have 10 replicas instead of 3. Okay. So Kubernetes is fulfilling this desired state for me. I'm not creating each of those pods manually, right? I'm just specifying, hey, you know what, Kubernetes? I want 10 replicas of this pod. And the specification of the pod is this, okay? This is great. This is great because actually this is the one of the main traits of Kubernetes, fulfilling the desired state of things. So let's verify this. What happens if I delete this pod, which in this case, it has the front end dash 47 blah 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 name. Okay, what's that name? Remember that when we created the pod manually, I had the chance to name the pod with whatever name I wanted, right? In this case, it's using the name of the replica set, which is front end, okay, and then a hash name, okay. So it's making sure that those pods have different names and, of course, different IDs. So what happens if I delete the front end dash 47 blah blah blah? Let's do this, okay. Kubectl delete pod and then the name, okay, and then I execute again get pods. So I was fast enough and quick enough to execute the get pods command again to see that the 96 pod, this one, is being created, right? So if I execute again this is running, so there's no the old pod was deleted. However, because of the desired state of things, Kubernetes is fulfilling that and is creating an additional pod for me, because I want to have 10 instead of 9, right? Makes sense? So this is actually the heart of Kubernetes, fulfilling the desired state of things. So I have 3, 4, 5, 6, 7, 8, 9, 10. Okay. And I can identify this newly created pod because of the age, right? Cool. And I can also query for those ReplicaSet objects. So actually, you can execute kubectl get and then ReplicaSet, okay? Or another alias is rs. So as you can see, I have this front-end ReplicaSet, and it's telling me some important and interesting things, such as the desired number of pods and how many pods are currently running. Cool. So I can also use kubectl describe and the name of this ReplicaSet. So as you can see, if I execute the describe command against the front end ReplicaSet, I'm obtaining all the details about that ReplicaSet. So it's telling me that those pods were created, right? And there was this last pod that was created after the fact. Cool. And what happens if you delete the ReplicaSet? So let's do this. Kubectl delete ReplicaSet, and then the name, which is front end. And of course, those pods will be deleted. Okay, the pods will be deleted automatically if you delete the ReplicaSet that was controlling and grouping all those pods. Okay, makes sense? That's why the match labels and some of those things are. I'm gonna describe that and explain that maybe in a couple of sessions. However, we can see that if you delete the ReplicaSet, all the pods will be deleted as well. Cool. So now let's talk about deployments. The deployment is the object that we actually use most of the time, generally speaking, when deploying applications in the Kubernetes cluster. Okay. Actually, it's almost similar to the ReplicaSet. It's almost the same. However, the deployment has a trait, a different trait, which is controlling the rollbacks and rollouts of those applications in a safely way. So the deployment object enables you to deploy and manage updates for pods in a cluster. Yeah, I guess you can use ReplicaSets in real world applications. However, you use deployments most of the time because the deployment uses a ReplicaSet inside. Okay. And it manages the lifecycle of pods. Because if you create a pod manually, that pod is not going to be relaunched if it fails or something. Okay. That actually is the responsibility of the ReplicaSet, and of course, there's a ReplicaSet inside a deployment. The thing is that if you changed a ReplicaSet, it wouldn't take an effect on existing pods. Okay, so for instance, if you want to, I don't know, let's change the, I don't know, the resource limits, or even the image name. Okay, if you change the image name and some specific properties about the ReplicaSet, such as the spec element, the replica set will not do anything special, okay? This is important. That's why the deployment is better in this case. And actually, that's the object that we use most of the time, okay? And this is why this is telling me that it's a higher abstraction, okay? It wraps one or more replica sets, and it provides control rollouts. And of course, you can roll back those rollouts as well. So yeah, the best practice is to use a deployment. Let's create our deployment and let's see what happens, okay? So let's go back here and let's create my deployment.yaml. And here I'm gonna write deployment. I'm gonna press tab. And again, this is the deployment object, which is inside the apps /v1 API version, very similar to the replica set, okay? And actually, I think this is basically the same, okay? Let's change those values. For instance, the name of the application, say my deployment, okay? And the image name will be Nginx, and the container port will be 80, okay? I just want to get rid of that resources element, okay? It's okay. It's okay if I have this yellow squiggly line. It doesn't matter right now, okay? So let's compare those two files. As you can see, of course, kind is different, right? Metadata, of course, the deployment has the name, and the replica set has labels as well. So I guess it's almost similar, right? So let's change the number of replicas inside the deployment. Where will be the place where we can implement this replicas element? So this is inside this spec, okay? Replicas, okay. Let's do this. Let's go back to the terminal. Let me see if I don't have any kind of replica set. Okay, I deleted all the pods by deleting the replica set. Okay, let's execute kubectl apply and then the name of the file, which is my deployment.yaml. Okay, so the deployment is created successfully, and now let's see kubectl get pods. Okay, so as you can see, again, I have 10 pods. However, this time the name of each pod has the name of the deployment dash, and then the name of the replica set dash, okay, and the hash, okay, instead of just using the replica set prefix, okay. And another thing is that the name of the replica set was created randomly, okay. This is another hash string, okay. And let's see what happens if I execute kubectl, okay, get replica set. And the name of this replica set is my deployment dash that randomly created name. The desired state is 10. 10 pods are running in this moment. And now I can get all the different deployments. Okay, get deployment or get deployments. Those two are alias. Okay, and I have my deployment object that I just created. It says ready 10/10. This is I wanted 10 pods and 10 pods are running. Okay, this is the summary of that line, and some other things such as up to date and available and DH. Okay, let's see what happens if I execute O-wide. As you can see, this is telling me some other things such as the containers, images, and the selector, which is a topic that I'm going to explain when I explain labels and annotations, okay? Cool. So this is telling me that everything is running correctly. I have 10 pods inside a replica set that is inside a deployment, okay? So everything is running correctly. What happens if I changed one of the elements inside the deployment object? In other words, what happens if I go back to Visual Studio and edit the, I don't know, maybe the spec of the container? Let's do this. However, let's go here to hub docker.com and search for nginx because I need other tag. I don't know, maybe 1.22, okay? 1.22. I want to use this other image name. Of course, that's a different image name, right? So what happens if I apply this YAML file again? kubectl apply, my deployment, okay? It's telling me that it was configured, and now let's execute pods, get pods again. So this is interesting because those pods, all the pods were terminated gracefully, and then it's starting and creating other pods, okay? Right now, all new 10 pods are running right now. However, I had 10 pods that were using the nginx image name, and then I changed the image name to use the 1.22 tag, and then Kubernetes detected that and gracefully terminated all the previous pods and created new ones, okay? Without me doing anything. Again, this is the desired state of things. This is the promise theory that Kubernetes offers, right? Let's do that again. Let's change this image name to other thing. I don't know. You know what? Let's use Redis or MySQL or something. It doesn't matter. I just want to change the image name, and I want to download another completely different image name so I can have enough time to show you the things that are happening in that particular moment, okay? So I'm changing the image name to Redis, and let's apply this deployment again. Let's execute get pods. And as you can see, those new pods are being created, 1, 2, 3, 4, 5, okay? Some others were running at that moment, and now all 10 pods are running again. And I guess this is because I had Redis previously, so it wasn't what I expected. I expected to, to download everything from scratch. So anyways, I have a lot of different image names right now. Anyways, it doesn't matter, okay? It doesn't matter. This is being controlled and managed by the deployment object. Just make sure that you identify that those pods are being created again, and the previous pods are being terminated gracefully. Okay, so I think this is what I had for today. So kubectl get deployment, and the pods are being changed by the fact that I'm changing the manifest file. That's one of the traits about deployments. And yeah, so In the next session, I'm going to talk about services because those pods are running, right? However, it's not that you're going to query those pods directly. And let me show you why. Let's see what's going on here. As you can see, each pod has its own IP address, okay? However, pods could be terminated and could be created again. So the IP address and the name of course, the name of the pod is quite volatile, right? And the IP address as well. So it's not that you're going to query those pods directly. You're not going to execute nothing against those pods in a direct way. You need something in the middle, and that's the service object that we're going to deploy in the next session. And I'm going to talk about more things about the deployment objects, such as rollbacks and rollouts and the history of the rollouts and those things. Yeah, thank you very much for your time. And let's see if we have some questions. Okay. So the stream will end after I end the show. Okay. So thank you very much for your time, friends, and see you on the next session about this Kubernetes series.